The UK demolition and construction industry's various competence card schemes are deeply flawed. Even when the rules and protocols of obtaining a card are strictly applied, they're merely a snapshot, proof that someone passed a test on one specific day. But as we all know, that alone is no proof of on the job competence. Sadly, as we also know, that is merely the tip of the iceberg. If you know where to look and are willing to pay for it, these competence cards are easy to obtain without all those annoying exams. You can pay to have someone sit the test for you, or you can bypass the entire system and purchase a card from the black market over on Instagram. Just this week, we reported on a police raid at a CSCS training centre where it's alleged trainers were accepting payments to grease the wheels of qualification. And frankly, that's only a part of the problem with the training regime in general and with the card schemes in particular. We find ourselves trapped in a frustrating training conundrum. We're desperate for skilled operators, yet we face a massive, understandable reluctance to let unproven rookies loose on multi-million pound live sites. As a result, we'll rely on a system where foundational training often takes place in a classroom, theoretical, sterile, and entirely detached from the reality of a site. But there is potentially a better way. Last night, I hosted a live stream featuring Alan Limoges of machine simulator pioneer CM Labs. Their simulators are not designed to facilitate remote machine control, nor are they the first step toward autonomous operation and the eradication of workers from sites. Instead, CM Lab simulators are designed to inspire young people to enter the industry, allowing them to experience the feel of operating heavy equipment without the inherent risks and the inherent fuel costs. They're built to prepare workers for the realities of the field and to help them enhance their skills. And following last night's discussion, it's clear that high fidelity simulation potentially offers a path to not only safer training, but a more robust, portable, and verifiable standard of operator competence. Currently, obtaining a competence card in the UK is a bureaucratic and clerical experience rather than a true validation of skill. A trainee might sit in a room, pass a multiple choice test on safety demands, perform a brief practical assessment, and if they don't hit a cone, they're competent. And at best, that's a snapshot assessment. It captures an operator's performance on a single day, often influenced by the subjective opinion of an instructor. As Alan Limoges pointed out last night, a trainee might claim an instructor failed them simply because they didn't like my vibe. Conversely, a candidate might pass despite possessing inefficient or dangerous habits that the examiner simply missed in that narrow window. Digital simulators dismantle that subjectivity. When an operator trains on a simulator, they're not just completing a task, they're generating a massive, indisputable data set. The system records everything: fuel burn rates, idle time, downtime, down to the second, engine torque, hydraulic pressure, and track wear. That allows for an objective assessment based on hard metrics. An instructor no longer needs to rely on a gut feeling. They can say, to pass, you must achieve 80% efficiency, 0 collisions, and burn less than 5 litres per hour. Furthermore, that data transforms training from a Polaroid into a motion picture. Instructors can track trends over weeks, seeing if a student is actually reducing their fuel consumption or if their safety score is trending upwards. It provides a quantifiable trajectory of skill acquisition that a one-off practical test simply cannot replicate. A common point of resistance to simulator training is the increasingly archaic belief that it can't replicate the feel of a heavy machine. Critics argue that a screen can't replace the seat of a real dozer. However, the technology has evolved far beyond simple gaming engines. We're now dealing with engineering-grade physics. CM Labs, for instance, utilizes what they call Vortex Studio, a physics engine originally designed for engineering specifications. In a lesser simulator or a video game, events are scripted. If the player does X, the code triggers Y. But in a high-fidelity simulation, the machine and the environment are built with independent, rigorous physics. If an operator flips a machine in this environment, it's not because the software decided it was time for a game over or a break period. It's because the operator took a corner too fast with a heavy load, shifting the center of gravity exactly as they would in the dirt. That realism is vital for tactile feedback. Through motion platforms and OEM-grade joysticks, operators feel the vibration and the resistance of the earth. And that minimizes what is known as negative training, the acquisition of bad habits that occurs when a simulator feels too floaty compared to the real thing. If a machine can be overextended without consequence, the operator learns a false sense of security. And for the demolition sector specifically, the argument for simulation is even stronger. You can't practice demolishing the same building twice. In the real world, once a slab is broken or a column's been sheared, that specific training opportunity is gone forever. Simulators offer the ultimate luxury for a demolition trainee, the restart button. An operator can learn how to use a hydraulic hammer on a concrete slab, make a catastrophic mistake, and then instantly reset the scenario to try again. They can practice sorting debris with a grapple until they do it faster and cleaner every time. That repetitive, low-stakes practice builds muscle memory in a way that is financially and logistically impossible on a live site, where fuel costs a fortune and materials are finite. And obviously, this capability extends to safety. Operators can be exposed to dangerous scenarios that would never be risked in real life. They can experience what it feels like to tip a skid steer, clip a power line, or have a crane cable snap. Learning the limits of the machine in a virtual environment ensures they respect those limits when lives are actually on the line. And perhaps the most revolutionary aspect of shifting to digital qualifications is the portability of the training record. In the current analog model, an operator's history is often just a list of dates on a plastic card or a CV that may well have been embellished. A digital competence profile follows the operator. That has profound implications for recruitment. CV padding or resume padding is a known issue. An applicant might claim 10 years on a motor grader when they've actually only had 2. With simulator-based assessments, an employer can put a candidate on the machine for 10 minutes during an interview. The digital report will immediately reveal if their skills match their claims, saving the company the administrative and safety costs of hiring somebody that is lying through their teeth. This record also facilitates continuous professional development. Training doesn't end when the card is issued. Veteran operators can return to the simulator to sharpen their edge. A veteran might reduce their loading time from 2 minutes to 1 minute and 50 seconds through concentrated repetition, an efficiency gain that translates to thousands of pounds in savings over a year. Now, the UK already has the infrastructure to adopt this. The CITB is apparently exploring simulation technology, and the precedent exists elsewhere as well. In Germany, crane operators have been certified for real-world operation using simulator time because the fidelity was deemed sufficient by national certifiers. And of course, some might argue that time on a simulator doesn't truly prepare an operator for a real machine on a live site. And it's a fair point, which is why no one is advocating for trainees leaping off a simulator and being handed the keys to an excavator immediately. Consistently high scores on a simulator may not be definitive proof of real-world competence, but they are a far better guide than a piece of plastic bought on the black market via Instagram.